the power was 4/5?
5/4. 5/4.
5/4. Okay, perfect. So Stacy is asking, how can we simplify this without the graphing calculator? And remember, we have to create what it's called a prime number, or factors, better, factor tree, which you probably learned 100 years ago. 256, it ends in 6, so the prime number that I can divide 256 by first is 2. 2 divided by 2 is 1, and then I have 2 and 8. So 2 times 128 is 256. It ends in a even number, so it's divisible by 2 again. So then I get 64. And I can continue forever, right? But I already know what 64 is. It's 2 to the 6, but let's say we don't know. It ends in 4, 2 again, 32. It ends in an even number, 2, 16. It ends in an even digit, so 2 and 8. It's 2 and 4 and 2 and 2. 1, 2, 3, 4, 5, 6, 7, 8. So this is 2 to the 8th, everything to 5/4. I cannot stress enough. You will be very comfortable. You will acquire a lot of skills if the first thing you do is redo the problems we did in class or we do in class. It cannot be better. So now you copy the base, you have to multiply the exponents. I simplify. Of course, I'm not going to multiply. I will simplify first. 2 times 5 is 10. And that's how I get that 1024. Very good. Other questions? MyLab Math, I did not get the chance to. I was helping a student from my 191 class, so I did not get the chance to look. But by today, if you have not finished everything in chapter R, you are falling behind. Because everything we studied in chapter R is going to be used moving forward.
I have a question.
Yes.
On the previous question you just did, how did you get the 2 to the 10th again?
Copy the base, multiply the exponents. 8, this is 8 over 1. 8 times 5 over 4. I simplify by 4, I get 1. I simplify by 4, I get 2. 2 times 5 is 10.
Okay, thank you.
Better? Good?
Yep.
So I have the prime factorization here. This is called the prime factorization of number 256. Number 256 is identical with 2 to the 8th power. Very good question. Anything else? Do we have anything else from anything? Anything. So remember, for those of you who came in late, again, you have the lecture notes and the video lectures posted right after class. If I don't do that, I cannot record the next class because the hard drive is not that big. The files are over 560 mega, just one 20-minute video. So I will not be able to record. So I upload everything before I go to bed. Secondly, you have solutions to each and every homework posted next to the homework, right underneath. I would do this if I were you. Don't print them out because it's going to be a ton of papers. So don't waste paper. Just save them and go line by line. You already used the paper to write, right? So make comments on each and every line if you think you made an error, or talk to me and on your own solutions with a different color and say, oh, that's what I missed. I will understand. I understand now. I'm not going to make this mistake again. Okay? Good. So we are starting chapter 1 today. Anything for me? Anything else?
Can I talk to you later after class?
Oh, absolutely. Of course.
Thank you.
Of course. Anything else? Other questions from anything? Okay. So let's start again chapter 1. So, Stacy, was this correct? I mean, was this all you needed?
Yes, that was very helpful.
Okay, perfect. Good. So we're going to talk about now chapter 1. And as we wrote the title last time, it deals with a lot of things. So let's start slowly. So last time I started, and I'll start again with this in the same way. So if I have the square root of x, this is called an operator. It does something to x. What does it do? For example, if x is 9, it takes the square root, and the answer is 3. What about x squared? This is another operator. What does it do? Well, if x is 2, this operator squares 2, and the result is 4. And we can continue forever. There is one operator that is called LIM. LIM applied to a function. This is also a function, right? I can write the square root of f of x. So the same thing. It's an operator applied to a function. When x approaches a, I'll explain this notation in detail. But right now, I just want you to understand that this, I'm going to write it in words in a minute, this is a similar operator like the square root, like power 2, like anything else. So this is read in the following way. The limit of f of x, this is not fx, it's not f times x, please, it's fx. The limit of f of x as x approaches, I always run out of room, there is an E and S here, sorry. The limit of f of x as x approaches a from either side. I know it's a mouthful. And this is, look, it's just LIM, x, an arrow, and a. But this is the way we read it. So what does this do? It finds the trend. So obviously this has to be different, right? What does this do? It takes the square root. What, I'm muting everybody, so please unmute yourselves when you speak. So what does this do? It takes the square root. What does this do? It squares. What does this do to this function? It finds the trend of the function when x gets closer to a number. So let's look at a few examples and then some examples from the book, and then I'll explain more about the notation. So again, this has the property of doing something to this function. What? It calculates, or it determines, or it finds the trend where this is going when this is going to this. Okay, so here's an example. I'm going to put some numbers here. This is a function f of x. Let's say this is 3. Let's say this is 4. I'm making numbers up. So let's take a look. If x, maybe this is not a good color. If x gets closer and closer from the right of 3, like with 4, and then 3.5, and then 3.1, closer and closer to 3. Follow my marker, please. The function values, when this happens, the function values get closer and closer to what value?
3.
One more time. As x gets closer and closer to 3, the function values get closer and closer to
4.
exactly. We're talking about the y values. So I can write the limit. Okay, maybe this is not good. I can write the limit of f of x as x approaches 3 from the right with numbers larger with numbers larger than 3, it's a power. It's like this. So larger than 3, like 4, 3.5, 3.2, 3.1, 3.01, closer and closer from this side. What is the limit of this function then? The tendency is to get closer and closer to, again,
4.
very good. Let's try now from the other side. With numbers as x approaches 3 from the left of f of x. So follow my marker, please. As x gets closer and closer from the left with like 2.9, 2.99, the function values get closer and closer, closer and closer to which number?
4 again.
4 again.
Wow, okay.
So therefore, we can now conclude that the limit of this function as x approaches 3 from either side is, as long as both approach the same number from either side, the limit exists, and in this case is how much?
4.
That's it. So remember, trend, not value. We're not talking about value. We're talking about the trend. And you can say, I don't understand what you're saying. Yes, I know it's not clear, but it will be clear right now. So this is another f of x. Here I have 5. Here I have 3. And I'm going to ask you, what is the limit as x approaches 5 from other side of f of x?
3.
That's it. Although the function does not exist at this point, we don't care. We are talking about trend. And when we say x approaches 5, we specifically mean x does not equal 5. We don't care whether the function is defined here or not, or defined here. We don't care. The tendency from the left is 3. The tendency from the right is 3. The tendency from the left is 3. So the limit is 3. Not the value. We don't care. The value, if I ask you how much is for this function, how much is f of 5, what will you say?
Three.
F of 5, not the limit.
Oh, then 6.
That's it. As you see, it doesn't matter. This does not say what is the value of the function. No, this says where is the function going when x gets closer and closer to 5. As x gets closer and closer to 5 from either side, the function values slowly get closer and closer to 3. They are not 3. They are getting closer and closer to 3.
Where does the 6 come from?
I just put it in to throw you off.
Oh, okay.
To make sure that we understand that f of 5 is 6. So the function is not even here. It's not a full point, and the limit still exists. Now, before we look at some examples, I want to say this. Okay. So let's take a look at the situation. This is our new function. And I'm going to ask you the same questions again. The limit as x approaches 3 from the left of the function, the limit as x approaches 3 from the right of the function, and the limit as x approaches 3 from either side of f of x. So one thing I want to mention, the limit is considered to exist if it is a number. So if you say, I don't know, if you can't give me that number, then the limit doesn't exist. If you give me like infinity, infinity is a symbol. That's not a number. So the limit is considered to exist only if it is a number. Okay, so can anyone give us the trend or the tendency of this function when x approaches 3 from the left?
Two.
Very good. Can anyone give us the limit of this function or the tendency or the trend of this function? What is it approaching? Not what is the value. I'm asking what is it approaching? Very good. So now careful. As x approaches 3 from either side, I want you to give me a number. What is the tendency or the trend of this function? Can you give me a number?
Doesn't exist.
Thank you very much. Because you cannot give me a number, you have to say does not exist. And what about if I ask what is f of 3, which has nothing to do with the limit? What
Two.
will the limit, the value of the function at 3 is indeed 2. Awesome.